In speech processing system, speech quality is very important to measure the system performance, especially in speech communication. Speech quality test plays an important role to measure the produced speech and to enhance the system's capability. Here we will have a preliminary understanding of the speech quality test. Researchers have studied various factors that affect the performance of the speech processing system and developed a speech quality evaluation technology, which can be divided into two categories according to the evaluation subject: subjective evaluation and objective evaluation. Subjective evaluation method is based on the comparison of the original sound signal and the distorted sound signal by a large number of listeners, and classified the quality of the distorted signal according to a certain predetermined scale. It reflects the sound quality from the view of listening. Objective evaluation methods mostly use a specific parameter to characterize the degree of distortion of the sound passing through the digital system, and are usually realized by computer or test device. There are many indexes used in different systems, such as SNR and LP-based measurements. Often, objective measures are used to get a rough estimate of the quality. Subjective quality can be described as speech intelligibility and speech articulation. Intelligibility means knowing the approximate meaning of a sentence, while articulation means that every word and every sound can be heard clearly. Articulation has higher requirements than intelligibility. The most useful method in intelligibility test is DRT, diagnostic rhyme test. The most useful method in articulation test is MOS, mean opinion score. Subjective test is more reliable than objective test. Objective test is more convenient than subjective test. As to the objective speech quality test, SNR, signal-to-noise ratio, is one of the oldest and widely used objective measures. It was observed that classical SNR averages the ratio over the entire signal and does not correlate well with speech quality. Because speech energy fluctuates over time, SNR was calculated in short frames and then averaged. This measure is called the segmental SNR that agree well with the subjective quality. It is well known that the speech production process can be modeled efficiently with a linear prediction (LP) model. There are a number of objective measures that use the distance between two sets of linear prediction coefficients (LPC), calculated on the original and the distorted speech. The log likelihood ratio (LLR) measure is a distance measure that can be directly calculated from the LPC vector of the clean and distorted speech. The Itacura-Seto-IS distortion measure is also a distance measure calculated from the LPC vector. The septal distance, CD, is an estimate of the log spectrum distance between clean and distorted speech. Spectrum is calculated by taking the logarithm of the spectrum and converting back to the time domain. Spectrum distance is also a very efficient computation method of log spectrum distance. It is more often used in speech recognition to match the input speech frame to the acoustic models. As to the subjective speech intelligibility test, the diagnostic rhyme test is proposed in 1983. It uses word intelligibility test by doing a 2-item multiple choice to provide percent correct. Scores on the DRT test, which is widely used to evaluate military voice system. It is generally considered that when the DRT is above 95%, the understanding of the sentence is excellent. 85% to 94% is good. 75% to 84% is medium. 65% to 75% is poor. And 65% or less is unacceptable. In speech communication, the quantification of subjective quality usually uses subjective Mohs test. Mohs test methods can be found in ITUT standards P.800, P.830, mainly including ACR, absolutely category rating, DCR, degradation category rating, and CCR, comparison category rating. Excellent quality in the Mohs score means that the reconstructed speech and the original speech have very little difference in detail. And this difference will not be noticed if the comparison is not performed. Good quality means that the distortion or degradation of the reconstructed speech is not obvious, and you cannot feel it if you don't pay attention. Fair quality generally means that the reconstructed speech has more obvious perceptible distortion, but the naturalness and clarity of the speech are still very good. And it does not sound fatigue. Poor quality means that the reconstructed speech has strong distortion or degradation, and there is a sense of fatigue. Extremely poor quality means that the quality of the reconstructed speech is extremely poor, and the hearing is unbearable. In digital voice communication, Mohs is generally considered to be divided into high-quality digital voice in the range of 4 to 4.5, which meet with the quality requirements of long-distance telephone networks, and is often referred to as toll quality. Mohs score at about 3.5 is referred to as communication quality. Listener can feel the degradation of the reconstructed voice quality, but it does not hinder the normal call, which can meet with the requirements of most voice communication systems. Mohs score below 3 is referred to as synthesis quality. At this time, the reconstructed speech generally has sufficient intelligibility, but the naturalness and speaker confirmation are not enough. There are many international standards for sound quality tests. Besides Mohs test, there are some other subject quality test methods, such as conversational test widely used in VoIP application. Mature and ITUR BS.1116 are the commonly used methods to test audio and music signal. As to the objective quality test, the most common method is PSQ, Perceptual Evaluation of Speech Quality, which can be used to test the speech quality of narrow or wideband telephone communication. Later, POLQA, Perceptual Objective Listening Quality Analysis, is proposed to be a global standard for benchmarking voice quality of fixed, mobile, and IP-based networks. It can be applied for voice quality analysis of VoIP, HD voice, 3G, 4G, VoLTE, and 5G networks. ITU-TT P.563 uses an audible-based algorithm to measure the narrow-band speech quality without input reference signal. PAQ, Perceptual Evaluation of Audio Quality, is a standard to test the audio and music quality. E-model is mainly used to test the phone call quality in VoIP network. That's the end of this chapter. See you next chapter.